So I'm very grateful to the ECDP for giving me an opportunity to speak here in front of you all today. So my disclaimer would be that I'm a pathologist, and this is a collaborative effort between Rifa International University, National University of Science and Technology, Pakistan, and the University of Sheffield here. So I'm going to do this a little differently. I'm sorry, I figured I was doing a presentation on day 3, and everything I could have said has already been said. So I'm going to start with this case. So this is a 48-year-old male that came into a dentist's office. He had a lesion right here, and it was painful for a few days, so the dentist felt around it, thought it needed a biopsy, sent the biopsy in to what we're gonna call lab 1. So the lab 1 pathologist takes a look at the tissue, calls it benign, more specifically pseudoepitheliomatous hyperplasia for the pathologist here. The dentist is not happy with the diagnosis, so he sends it in for a review. That's how it landed on my tray. So when I took a look at the tissue, I called it oral squamous cell carcinoma, which is a type of oral cancer. At that point in time, I was very new into my practice, and I did not know the consequences of changing a benign diagnosis into a malignant one. But I learned very fast after this. So the family was obviously distraught, and there were threats of litigation. I kept insisting that they should go for another review. It took me a long time to convince them to get another review. Well, they did. So the tissue went to review to lab number 3. When this scan was done as well. So the pathologist said no cancer, but the scan said cancer. This is the tumor, by the way. So when the pathologist found out about the scan, went back to the sections and finally located the tumor. And he also declared it oral squamous cell carcinoma cancer. So this emphasizes the importance of everything we've been talking about. This does not mean we have bad pathologists in Pakistan. Everyone makes a mistake. But we need something to flag tissue and let us know that we need to take another look at it. This is going to be one of the most important things that the deep learning algorithms can provide for us. But I have another problem. I come from Pakistan, which is a developing country, and I can't afford equipment like this. I think the estimated cost of one of this is $40,000, and I have to pay tax on top of that and import duty. So this adds up. So my team and I came up with an idea in which we decided that we're going to use low-resolution images generated from basically microscope cameras or cell phone cameras. I take better pictures on the cell phone, so we ended up going with the cell phone ones here. So these are some of the approaches that we use, but let me get to this. So my job in all of this was that I was just supposed to locate a few things. I was supposed to let them know where 3 types of epithelial features were. You can see the mitosis here. And I was supposed to just mark the epithelium and keratin pearls, which are a characteristic feature of oral squamous cell carcinoma. So these were the 3 that we went with. We wanted to see if this model can work. So in order to detect all of these, we had to use 3 different approaches. For the mitosis, we used FRCNN. And for the epithelium detection, we had to rely on semantic segmentation. And for the keratin pearl detection, because we ended up using some cancers in which we didn't find a lot of keratin pearls, we had to rely on the GoogleNet architecture. So these 3 approaches were used to process the data. So for the mitosis, we generated a score of 0.65. And I know it's not the best compared to the algorithms, the state-of-the-art algorithms we have out there. But it has potential. The reason why it has potential is because now we can have every single pathologist with a cell phone generating data for us. And of course, we've heard over and over again how annotations are such a problem. If you have more people contributing, then you can have a global database for training purposes. These are our results for the epithelium. We need to increase our data set. Again, this was done only on 13 oral squamous cell carcinomas. Instead of whole slide imaging, we had to take multiple images of the same tumor. And those are the images that were processed through. Okay, so I believe that this opens up a scope in a lot of dimensions. One of the things that is key is that whenever I see whole slide images, they're perfectly stained. I mean, I can't get a section like that from my tech. There are artifacts in my slides. I have staining differences. So if I'm training with a data that accommodates all of this, I can possibly train a better algorithm. So these are a few things that we're continuing our work on, and we're going to keep proceeding. These are some of the things that we're currently working on, and some of the things that we would like to do in the future. And one of this I'm going to mention is that if we're using cell phone images, maybe we can have cell phone applications. There was a talk on developing countries and how this technology is difficult to locate over there. But if we take it onto a cell phone, I believe we can make it accessible to everyone in the world. Thank you. I'm happy to take any questions. And a thank you note to all my collaborators. If you want to speak to any one of us, Dr. Hassan is there, and he can answer all your technical questions, by the way. Acknowledgements to the ARC office, and this is the city where I'm from. Thank you. I'm happy to take any questions.
Any questions? Can you have the mic here, please?
I applaud you for your great determination and just to get these things done. That's fantastic. There are several algorithms that our community has been developing, and then we make these open source and freely available. So I would encourage you to look at some of these algorithms for some of the problems that you listed over there. And they will not solve all the, for instance, tissue preparation problems, for instance, but if there is staining non-uniformities and other things, we have some algorithms or to detect areas of problems. So you may be able to accelerate what you are doing using those algorithms.
Thank you. Thank you very much.
Hi, yeah, good work, by the way, yeah. So, I mean, I sort of had a question on one of the points that you mentioned towards the end about having, say, low quality images in terms of staining or artifacts and so on. Now, you know, we could control these images at the training time. I agree, I completely agree with that.
I suppose that's a possibility, yes.
Yeah, but then, you know, once the algorithm is in the field, for example, then we don't have, you know, any control, or at least we have much less control. Now, we could go two ways. One is to have an algorithm which is robust to these kind of, say, so-called adversarial examples, or we could have a quality check before the algorithms. Now, which of this is, from a pathologist point of view, which of this is
more feasible?
Yeah, more feasible or more practical?
Okay, so see the way you take an image, it depends on how experienced you are. I've been taking them for 4 years, so I'm obviously very savvy at them now. But when we start training someone else to start doing the same thing, it's a learning curve. Okay, so I think there are a few things that we were able to compensate for, and those were the brightness. It wasn't consistent because it really depends on how your mobile phone is arranged, because these were taken directly from a microscope. So we did compensate for some of them, but I did exclude the artifacts from the sample that was processed right now.
So with a bit of training, you could
with a bit of training, I suppose we can make it happen.
Thank you.
I will join in commending your resourcefulness. You know, I work in a very advanced, very resource-intensive, rich country, but I lived for many, many years in Argentina, and I know how difficult it is to get certain things. These things have more power than,
yes,
the cameras that we used to have in microscope 20 years ago. So, good thinking. I'm thinking that there are certain things that you could do to avoid these problems. Maybe talk to somebody to design a mount that gives you the right angle.
Well, I think some of them are available. As I said, that most of the data that was processed was collected by me. Mm-hmm. So I've gotten very good at it. I learned how to do this at Ohio State when I was doing my residency.
Of
So-
course, you're great at it, but you're not the only one that is going to be
Yes.
doing it, so
So
it will be
we
good
will-
to
we will need
engineer
them
the
out
human
for-
component out of it. But I think it's great, and please do keep in touch with the people that develop the algorithms, because we need these things to work not only in high-resource countries, we need these things to work everywhere.
Can we have a last question, please, if there is any? Gentleman at the back.
I would also like to comment that it's very impressive work that you're doing, and coming from a more engineering IT point of view, I would like to just make the remark that we should in general, I think more mobile first. And I think we could all benefit from having the applications not as installable software that has to run on a Windows machine, but more as a web service that can run on a desktop, on a pad, or on a mobile phone.